Hello guys, welcome to Tech Foundation. I am Eric Obin, aka Professor. This is the first episode of the tutorial series, and in this episode we are going to look at the Arduino platform. Arduino is an open source platform for building interactive electronic projects. It consists of a physical programmable board and a piece of software, or IDE, which stands for Integrated Development Environment, that runs on the computer. Now, using this IDE, you can write codes to run on the physical Arduino device. The Arduino platform is very popular, and there is a worldwide community of students, hobbyists, designers, and professionals all making contributions to this platform. This also makes it very easy to get help when you need it. It being an open source platform means that the boards and the software are readily available and anyone can modify and optimize the boards for better functionality. Now, another thing that makes it great to use, unlike most other hardware, is that it does not require any external programmers for loading code onto the device. All you need is a USB cable connected to your computer. Additionally, the Arduino IDE uses a simplified version of C++, making it easier to learn to program. We already have an ongoing tutorials on C++ programming on this same channel. I will urge you to check it out and subscribe. The Arduino provides a standard form factor that breaks out the functions of the microcontroller into a more accessible package. For this reason, there are various Arduino boards which are classified according to the type of microcontroller they use or their package. We have the Arduino Uno. This is an example of the Arduino Uno. We have the Arduino Uno, Arduino Nano, Arduino Serial, Arduino Mega, Arduino Due, Arduino Leonardo, Arduino Yan, Arduino Ethernet, etc. There are a lot of boards out there. Now, these boards may vary in the type of microcontroller used or the size and form factor. For instance, Arduino Uno and Arduino Nano both have the same Atmega 328 processor, but they differ in form. Also, the Arduino Mega and Arduino Leonardo have the same form factor, but they use different microcontrollers. The Arduino Uno uses the Atmega 328, Arduino Leonardo uses Atmega 32U4. These are the things that keeps varying from one microcontroller board to the other. Now, in this tutorials, we will be using the Arduino Uno microcontroller, as you can see. So Arduino Uno is one of the most popular boards. It has a USB interface which you can connect a USB cable and then connect it to your computer. To make things clear, the Arduino is the microcontroller board and not the microcontroller itself. That is to say that the Arduino is the circuit that has been designed around the microcontroller, which in the case of the Uno is the Atmega 328P. So if you take the Uno, this is the microcontroller. Okay, so this Arduino board is the circuit that has been designed so that you can easily make use of this Atmega 328 microcontroller. So the Atmega 328 is the microcontroller and it has a built-in microprocessor. It is very easy to get a hands-on experience with Arduino. However, it requires a little bit of technical expertise to work with just the microcontroller. So I can actually take this microcontroller from this board, okay, and build my circuit around it. But then before you can do that, it means that you should have a firm background in electronics. Using the USB cable, you can program the Arduino hardware from Windows, Linux, or Mac using the Arduino IDE. All you have to do is to download and install the IDE version for your operating system. I will take you through the installation process in a future video. Now, before you can use the Arduino Uno, you have to power it first. You can power the Arduino using the DC barrel. So this is the DC barrel. Okay, you can slot in a DC jack, or you can power it through the V-in pin here. Okay, so I don't know if you can see. So you can also power it from this pin. Now internally, this V-in pin is actually connected to the DC barrel. So it means that if I put in a voltage through the DC barrel, that voltage would also appear at the V-in pin, okay, and vice versa. The Arduino operates on 5 volts. Therefore, there is a 5-volt regulator which converts the input voltage to a fixed 5 volts for the microcontroller. Now, when powering the Arduino Uno via the DC barrel or via the V-in, the voltage level should be between 7 to 20 volts. This is because the 5-volt regulator is a linear regulator and it requires at least 2 volts for its internal circuitry. Now, from experience, I recommend a minimum of 7 volts and a maximum of 12 volts, because what I've realized is the higher the voltage, the less efficient the 5-volt regulator becomes, and more heat is dissipated, which will end up warming this side of your board. Now, efficiency is calculated as energy output divided by energy input, all multiplied by 100%. So, for instance, if you use a 7-volt power supply, then the efficiency of the voltage regulator is going to be about 71%. When you use a 12-volt power source, the efficiency will drop to about 42%. So using a 20-volt power source would give you an efficiency of 25%. Now, this is not good at all, because remember, energy can neither be created nor destroyed, but can be transformed from one form to the other. So the way this voltage regulator actually deals with the excess voltage is to dissipate it as heat, which is not good for the Arduino. So if you give it that much of power, you always see that this side of your board will be heating up, and eventually it can lead to the breakdown of this voltage regulator. So the recommendations that I will make is that if you can have a 9-volt power source, use it, or at most use a 12-volt power source. The Atmega 328 microcontroller on the Arduino Uno is a TTL. Now, TTL stands for transistor logic. So it is a TTL logic, it's a TTL device. Now, this means that its operating voltage level is 5 volts. Each digital pin on the Arduino Uno. So here are the digital pins. So we have from pin 0 through pin 13. These are what we call the digital pins. Now, each of these digital pins is capable of sourcing a maximum of 20 milliamps of current. Now, this means that you always have to make sure your power supply is capable of delivering the amount of current that your application requires. So, for instance, let's say you are controlling three devices using pin 6, pin 7, pin 5. That means let's assume those devices are pulling 20 milliamps. Then it means that you will need 20 plus 20 plus 20, which is a total of what, 60 milliamp, together with whatever this whole board itself is consuming. So that means your power supply should be something that can at least draw about 100 milliamps or 120 milliamps of current. Now, the Arduino Uno, or to be specific, this Atmega 328 IC has a 32 kilobyte flash memory. Now, the flash memory is where the instructions or the program that you upload onto the Arduino is stored. For most beginner projects, this is a lot of space. However, I have actually run low of this space in many projects. Okay, and out of this 32 kilobytes, about 0.5 kilobytes of it is reserved for what we call the bootloader. Now, for now, what I want you to understand about the bootloader is that it contains a sequence of instructions that helps to start your microcontroller. Now, I will make a separate video on bootloader in the future. Before a program can be executed in any computing environment, it has to be loaded into memory. This is no different for the Arduino. So the Arduino Uno or the Atmega 328 IC or microcontroller has a 2 kilobytes SRAM or static RAM, which we mostly call memory, and it can be used to store variables. So this SRAM or memory is actually a volatile memory. What I mean by a volatile memory is that once the power is off, everything you store in that memory is lost. Okay, and again, for newbie projects, this is enough. This is enough. You can do a lot with that 2 kilobyte memory. There is also a 1 kilobyte electrically erasable and programmable read-only memory, which is also known as EEPROM, which is a type of non-volatile memory. So it can be used to store data permanently in the microcontroller. So whenever there is a need to add some data persistence to your application, you can use the EEPROM to store that data. However, one thing that you should know is that this EEPROM has a maximum write cycle of about 100,000. This means that erasing and rewriting the EEPROM this number of times will make it unstable. Okay, so if you are using the EEPROM for data persistence, you have to be very careful how many times you write and erase. The Arduino Uno has an onboard LED. So this LED here, this small thing here is an LED, and this LED is internally connected to digital pin 13. And the purpose is for testing the board or for doing hello world programs without having to set up any external circuitry. So when we look at the software aspect of the Arduino, I will demonstrate what I mean by hello world program. Now, if you look at this side, so if you look at this side, this particular port here, we call it the power port. You can see that we have already talked about the V in. Now we also have the two ground pins here. Ground serves as the reference point for the circuit. Okay, so the point of convergence of the current. We have this 3.3 volts here. Okay, we also have a 5 volts here. The 5 volts can also be used to power the Arduino. So the way you can power the Arduino is one via the V-in, or via the 5 volts pin, or via the DC barrel, or via the USB port. If you power your Arduino using the 5 volts pin, it means that you bypass this voltage regulator. So whenever you are using this, you have to be very careful, because any spike on this 5 volts can end up destroying your microcontroller, because it is directly connected to the microcontroller. So this 5 volts pin can also be used to power external devices. So it is a bidirectional pin. It can be used as a means of powering up your Arduino, or it can be used as a means of powering external or other circuits connected to your Arduino. However, this 3.3 volt pin here is just for output purposes. You can't use it to power the Arduino. But then if you are using a circuit that has let's say that requires a 3.3 volt source, then you can tap power from this 3.3 volt source to power that particular circuit without having to go find for yourself another power source or that kind of thing. However, this 3.3 volt power source is actually used for low level current applications. It can supply just about 50 milliamps of current, so you don't use it for current heavy applications. If you look at this side of the board, there is a pin. You know whether the camera is zooming. Okay, let's wait. Good. So there is this pin called the IO ref. Okay, stands for input output reference voltage. Now, this IO ref, what it does is it provides the reference voltage for the microcontroller. So if you pick any microcontroller and you want to know its voltage, operating voltage, you can just put in your multimeter at this pin and read the value. So for an Arduino Uno, because it's a TTL device, if we read this value, this IO reference value, we should get something like a 5 volt. Now, the pin closer to the IO ref here, you see that it has no label. Okay, so it actually does nothing. It is there for future compatibility purposes. Okay, now there is also a reset pin here. Okay, there is a reset pin here. Now, this reset pin is actually connected to this reset button. If I power this Arduino and load some code onto it, when the code starts executing and I want it to be start all over, I can press this reset pin or reset button, and the program on the Arduino will start executing from the top to bottom. You see that if you embed this Arduino into a project, then it wouldn't be convenient to be opening the project to press this reset button when you want to do such a thing. So by extending or breaking out that reset functionality on the pin, it gives you the ability to interface your own push button to control it manually or externally. The reset pin is an active low pin. What I mean by active low pin is that it is activated on a low signal. So by default, it is always pulled high. Pulled high means it is always connected to the 5 volts level. Some pins on the Arduino Uno have special functions. These include digital pins 0 and 1. Okay, so this is digital pin 0. Okay, so you can see the label here. Okay, so this is digital pin 0 and this is digital pin 1. Okay, now these two pins are used for what we call serial or UART communication. Now, UART stands for Universal Asynchronous Receiver Transmitter Communication. Now, digital pin 0 serves as the receiver or the RX pin, and digital pin 1 serves as the transmitter or the TX pin. Digital pins 2 and 3, okay, as the label shows, are capable of external interrupt. Interrupt basically is a way of suspending the microcontroller's current execution to do something else for a brief moment of time. 6 digital pins, digital pin 3, digital pin 5, 6, 9, 10, 11 are capable of what we call pulse width modulation or PWM functions. They can provide an 8-bit PWM output with the analog write function, which we will look at later when we start coding the Arduino. Now, these pins, if you look on the labels, you realize that the pins that I just mentioned, 3, 5, 6, 9, 10, and 11, they have this small tilde sign in front of them. Okay, so the pins with the tilde sign are the pins that are capable of this pulse width modulation function. Now, I'm going to explain or make a separate video on pulse width modulation in future. Now, the Arduino Uno is also capable of a special function known as SPI Communication. Now, SPI Communication is one of the ways the Arduino can communicate with other devices. Okay, so the pins that are used by the Arduino for this SPI communications are digital pins 10, 11, 12, and 13. So in SPI communication, these are the pins that you need. And digital pin 10 is used for a chip selecting or slave selecting, a concept that you will understand in future. Then digital pin 11 is what we call master out slave in, or MOSI. Then digital pin 12 becomes our master in slave out. Digital pin 13 becomes our serial clock. So I'm going to make a video tutorial on SPI communication, and you would get a good understanding of what I mean by all these terminologies. There is also another form of communication protocol called the I2C, or twin wire communication protocol. Arduino Uno is also capable of this communication. It is also a means that Arduino can communicate with other devices. Now, for the twin wire communication protocol, the Arduino uses just 2 pins, and here it uses analog pin A4 and A5. So analog pin A4 serves as the SDA, or serial data line, and the analog pin A5 is used as the SCL, or the serial clock. Now, if you look at this side, you realize that there is another ground pin here, okay, right beside pin 13, digital pin 13. There is a ground pin, and there is an AREF pin here. Now, this pin labeled AREF stands for analog reference voltage. Okay, it's the reference voltage for this analog input. So whenever you are doing any activity with this analog input, the reference voltage is set by this analog reference pin. So if you know your way around it, you can actually modify the default. If you know your way around it, you can actually modify it externally, but you have to do it with caution. Now, by default, it is 5 volts. Arduino Uno can be used in many applications, including home automation, robotics, industrial automation, parking lot counter, and many more. Your creativity is actually your limit. I believe you have learned enough about the Arduino Uno board. Remember, if you can manipulate the building blocks, you can build anything. So make sure that you understand this lesson before moving to the next. I don't want you to be in a hurry to do the cool stuff. Pay attention to the basics. Alright, thank you for watching, and see you in the next tutorials. Let me know what you think through comments, and don't forget to subscribe to receive notifications for future videos. Also, try and share this gift with your friends and families. What are friends for? I am Professor, and this is Tech Foundation.